Hi, my name is Balázs Holzer from Budapest, Hungary, and welcome to my course on cryptography and hashing algorithms. So first of all, let me tell a few words about myself. I'm from Budapest, Hungary, as I said earlier. I'm qualified as a physicist, and later on I decided to get a master's degree in applied mathematics. I'm working as a software engineer at a multinational company, and my main interests are algorithms, data structures, and artificial intelligence. So what you are going to get from this course? We are going to talk about several topics. First of all, we are going to talk about cryptography fundamentals, so what is the difference between symmetric and asymmetric encryption, and then we will focus on private key cryptography or symmetric cryptography, such as Caesar cipher, how to crack the Caesar cipher with brute force approach and with the help of frequency analysis, how to detect languages. We are going to talk about Vigenère cipher, how to crack the Vigenère cipher with Kaczynski algorithm. We will talk about the one-time pad. We will talk about randomness in cryptography. And what's extremely crucial, that we are going to use Python as well as Java as programming languages. So if you are interested in Python as the programming language, then of course you have to follow the Python implementations. If you are interested in Java programming language, then you can follow the Java implementations. Okay, then we will consider further private key crypto systems such as the data encryption standard and the advanced encryption standard. And then we will consider asymmetric or public key cryptography. Of course, first we have to talk about modular arithmetic, such as what are prime numbers, how to find prime numbers, what is integer factorization, what is the discrete logarithm problem, and so on. Then we will talk about the Diffie-Hellman key exchange algorithm, then the RSA algorithm, and finally we are going to talk about elliptic curve cryptography. The third large topic has something to do with hashing algorithms. So we will talk about why hashing is crucial in cryptography. We will talk about the properties of hashing and the famous birthday paradox, and we will talk about several hashing algorithms such as MD5 algorithm, SHA-256 algorithm, and so on. We are going to talk about cryptocurrencies such as Bitcoin and Ethereum because they rely extremely heavily on elliptic curve crypto systems. We are going to talk about wireless communication, and we will talk about HTTP, HTTPS, SSL, and TLS protocols on a one-by-one basis. So these are the topics we are going to consider. Thanks for joining my course. Let's get started.